Hi guys, so this is our second video on differentiation under math studies. We are still in level 1 basic problems, and this video shall focus on introducing problems with turning points. I shall begin the first question shortly. Hi guys, we shall now solve paper 2 May 2000 question 8I. Take a minute to look at the question and attempt to solve, and the answer shall follow through shortly. Please note that AII is not included in your current syllabus, so you do not need to attempt to solve it. So in question A, you are told for each of the following points, state whether it is a maximum point, a minimum point, or a point of inflection. We are concerned with AI for now, so AI, which is point B, is obviously a maximum point. This right there, for your information, is a minimum point, and D is what we call a point of inflection, and you do not need to worry yourself about that for now. So in question B, you are required to describe the gradient of the curve in passing from the point B through C to D. So at B, since this is a turning point, the gradient is 0. From B to C, since the function is decreasing, the gradient is negative. At C, we have another turning point, hence the gradient is also 0. Next, from C to D, since the function is increasing, the gradient is positive. At D, this is what we call an inflection point, and the gradient is also 0. How do you know that the gradient is 0 at any point? When we have horizontal tangents. So at B, if I try to draw a tangent, we will notice that it's a horizontal line. Similarly, at C, the tangent is a horizontal line. Similarly, at D, the tangent is a horizontal line. However, at point A, for example, the tangent is not a horizontal line. It's an inclined line. And at E, the tangent is also an inclined line. So when the tangent is horizontal, the gradient is 0. So moving on, question C says D has coordinates A and f of A. The x coordinate at E is A plus 4. Write an expression for the gradient of the line segment DE. So let's take a look at how to do that. So we know that the gradient for any 2 points, x1, y1 and x2, y2, shall be given by y2 minus y1 over x2 minus x1. The 2 points given in the question are A f of A and A plus 4, and the y value when x is A plus 4 shall obviously be f of A plus 4. So there is my y value. These are my 2 points. Hence the slope shall be y2 minus y1, there they are, over x2 minus x1, and there they are. Hence this is my equation for the gradient or the slope. All that remains is for me to simplify the denominator. A plus 4 minus A gives me a 4. Hence this is my final equation for the gradient. So take a minute to write the answers down if you will. I shall begin the next question shortly. I shall now solve paper 2 November 2003 question 8I. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So you are given a curve, and in question A you are required to find the values of x for which f dash of x is 0. So f dash of x is 0 when the tangent line drawn at a point is horizontal. This applies to this point right there, this point right there, and this point right there. So the tangents are horizontal at these points, hence the slope is 0 there, there, and there. Hence the values of x corresponding to 0 f dash are 3 and 5 and 7. In question B, you are required to state the range of values of x for which f dash of x is negative. F dash of x is negative when the function is decreasing, and the function is decreasing starting at this point and up to this point. So anything within this region right there has a negative slope because the function is decreasing. Hence 3 less than x less than 5. Make sure it's less than, not less than or equal, because at 3 and 5 we said that the slope is 0, not negative. So this concludes our question. I hope you have found it easy. I shall now attempt to solve paper 2, November 2004, question 8I. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So in A, you are required to find the intervals from A to L in which f of x is increasing. Obviously, these are the intervals from B to D, from G to K, and from K to L. Not from G to L, because at K the function is not increasing. At K the function is horizontal. The tangent is horizontal, so this is a turning point or something called an inflection point. So you cannot say from G to L. You have to say from G to K and from K to L. Next, I want to find the intervals from A to L in which f of x is decreasing. So obviously from A to B, from D to G. In C, I want to find a point that is a maximum value. So this is obviously point D. Then I want to find a point that is a minimum value. So this is either B or G. So there are your answers. I hope you have found this easy to understand. I shall now attempt to solve paper 2, November 2005, question 8I. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So in question A, we are required to differentiate f of x with respect to x, where f of x is this function right there. So this is simple differentiation. X to the power of 3 becomes 3x squared, 7x squared becomes 14x, and negative 5x becomes negative 5. As for the 4, which is a constant, it vanishes during differentiation. Next, I'm required to calculate f dash of x when x equals 1. So in order to calculate f dash of x when x equals 1, I've written the function down, the original function, not the derivative function. So this function right there, I've written it down on my calculator. I've adjusted my window as follows, and by clicking on trace, I've obtained the picture of the curve. Now to get f dash of x when x equals 1, I simply press on second, trace dy by dx, which is here option number 6, and I type 1 into the calculator. Excuse me. I press enter, and the calculator tells me that f dash or dy by dx is actually equal to 12 when x equals 1. Of course, the manual way to do that is to simply plug x equal 1 into f dash of x. So I'll just replace this x with 1 in all of the equation. And if you do it manually, you should also get the same answer, which is 12. You can actually do it manually and using the GDC to confirm your answer if you would like. In question C, I'm required to calculate the values of x when f dash of x equal to 0. So this is simply achieved by setting this green equation right there to 0, and this is what I've done. You can either do it using the GDC or you can do it using factorization, which I personally prefer. I find it quicker, but this is up to you. And the answers are x equals -5 and 1/3. In question D, I'm required to calculate the coordinates of the local maximum and the local minimum points, and I should know that these 2 points are points where f dash of x equals 0, hence their x values are the values that I've obtained in question C. So this builds on the previous question. You already know the x coordinates of the 2 points, so you only need to find the y coordinates of the 2 points, plus the fact that there is also a way using the GDC to find the local maximum and the local minimum. So let's take a look at the GDC approach. So I shall press on second, trace minimum. I shall choose a left bound and then a right bound and then a guess as to where the minimum point is, and the calculator tells me that the minimum lies at x equals 0.3333, which is 1/3, and y equals 3.148 or just 3.15. Hence these are the coordinates of my minimum point. Let's check the maximum. Again, second, trace maximum. I need to find a point to the left of my maximum point. So there, roughly, this is where my maximum is. So there is my left bound, and there is my right bound, and there is my guess. So the maximum lies at -5 and 79, which is what we have written right there. Of course, there is a manual way to do this, and you should know it because sometimes you are actually given the credit for the workout. If there are more marks allotted to this question, you shall probably need to show your workout. So you already know the x coordinates. You just need to identify which of these is the minimum and which of these is the maximum. And the way to do so is to get the second derivative of the function simply by differentiating the first derivative, which is right there. So I'm going to differentiate this green function to get f double dash of x, which is right there. Then I'm going to plug the two values of x and see the values of f double dash. So when x equals -5, f double dash is -16. Since the value is negative, hence this is a maximum point. So you should know that the maximum point is a point where f double dash is always negative. And since when x equals +1/3, f double dash was equal 16, hence I should know that this is the minimum point. So the way to distinguish between maximum and minimum is by using f double dash of x. If f double dash of x is positive, then this is a minimum point. If it is negative, then this is a maximum point. Finally, you just need to get the y coordinates by simply plugging the 1/3 into this equation, or using your GDC to just find the y values at these points. So there are two different ways in order to find the maximum and the minimum. Finally, in question E, you are required to draw the graph of f of x, indicating clearly the local maximum, local minimum, and y-intercept. So this is what your graph should look like. Make sure that your answers are reflected in the drawing, so the maximum point exists at -5 and 79, whereas the minimum point exists at 1 over 3 on the x-axis and 3.15 on the y-axis. So there are two marks for that. And labeled axes, of course, there is a mark for that. Finally, there is a mark for the y-intercept, which is right there. So this concludes our question. Take a minute to write this down if you will. I hope you have found this useful.